Hi everyone, welcome back to the channel. Today I'm going to show you how I'm going to use the bagging regressor and try to predict the prices for today. So I will be using the Nifty OHLC data, the daily data, and I'll try to predict using the bagging regressor, and we'll see if it's good enough or not. So I've already imported all the important libraries, so pandas, numpy, sklearn, and all the models and the ensemble from the sklearn. So let's start with that. So I'll be making my data frame. I will be just reading the CSV. I have already uploaded the OHLC data of Nifty. So let me show you how that looks like. And it also has the previous closing price. So I'll just show you how that looks like. And this is how the data is. So it's daily data frame. It's on Nifty. We have the open, high, low, close, and we also have the previous close. So I will be using the previous close and try to predict what is going to be today's close. So let me just change the date time format. .pda.data frame df, and let's check if it's coming fine. So let me just check the shape. Okay, there is some error. Let me check what is the error. Okay, should work fine now. Yeah, we have got the shape. So let me now define the features. So I'm going to define my input and output features. So my input features is the today's open price and the previous close. So I will be using these two as the inputs, and my target will be the closing price of today. And let's now train and test let's split the data into train and test. So x is equal to df, and I am using the features as my x variable. My y variable becomes my target, and x dot train comma x dot test comma y underscore train y underscore test is equal to train test split x comma y comma, and let's do the test size of 0.3, and I'm going to save the random state so that you can use the same data frame at your end as well. And let's just print out. So I'm just going to print out the x train dot shape and the x test dot shape. So let's see if it's coming fine. So we've got the we've already split the data. Now let's plot it also. Let me show how to plot it. So train is equal to df dot log, and I want all the values before, let's say 01 01 2021. That becomes my training data, and my test data becomes all the values after that. That means 31st 12 2020, and then figure ax is equal to plt subplots. So I'm just finalizing my figure size. Then I will put my training data on the plot. So I'll call it training set, and similarly I'll put my test data, and I'll call it the test set. So we've got both the data added. I'll be adding the AXV line. Basically this will demarcate my testing and training timelines. And let's just add the legend, and let's just show the data now. So let's show the plot, see if it works fine. Yeah, so we've been able to um, plot the data also. So the first part is your test data and the second part is the training data. All right, so let's do the regression now. So I'm going to actually do the regression. So regressor is equal to bagging regressor, and I'm putting the base estimator as the decision tree. So this is one of the hyperparameters, you can say so. And let me just fit my regression now on the training for y and the x and y. So let's do this. Okay, there is some error. Let's see what is the error. Okay, if not fit, it's fit. It should work now. So we have got the regression done. Let's now try to predict the value. So y underscore predict is equal to regressor predict, and I'm going to predict it based on the x test. So this is the predicted value now. So let's first evaluate the performance on the training data set. So I will require my predicted values, which is regressor dot predict, and I will be now putting the training data set here because I'm going to calculate the predict value using the x train. My r square is r2 square, and it's between the y train, which is the actual data that we have, and the predicted data that we have predicted using the x train. Similarly, we're going to find the MSE, the mean square error, which is your mean squared error between the y train and the predicted value. And then we'll find the MAE, which is a root mean squared error. So sorry, absolute error. So mean absolute error is equal to y train comma predict. We can even find the root mean square, but that's okay. Let's just print out all the results that we've got. So r square is r2, the MSE is the MSE, and the MAE is MAE. Let's see how the results are coming. So this is based on the training data. That means it's the actual data. And if you look at the 35 points, which is the absolute error on a daily basis, this is pretty large. That means on average, the predicted value is about 35 points away from the actual value of Nifty. Considering that Nifty moves only say 100 points in a day, this is very far away. So doesn't look like we're able to predict it well. So anyway, let's see how the evaluation is working on the testing data now. So we will not be requiring this anymore. So I'll just remove the predicted part. We already have the predicted part at the top. So my r square is now y test. So this is the testing data we'll be using everywhere, and it's going to be against the y pred, which we have predicted here. So let me just copy this everywhere. Let's run it, and now you can see even worse performance actually. So what this shows that it was able to do 35 MAE on the training data set, but the testing data set is very bad. It's almost 90. So again, doesn't look like a great regression. So let's try to plot it. So test OHL, test features, and let me just update the value of ipred. So plt.rc params figure.fig size, let's say 2010. I'm going to plot the test index comma test targets, and let's call them in red. And this is the actual data that we are plotting, which we have. And then we'll plot ypred, and this is the prediction, and let's call it the prediction. Let's add the title. Let's add the labels now. Let's add the legend. And let's show it. So I'm going to show it now. Let's see if it works, right? So as you can see, the results are not too good. The results are not too good. The predictions are not very smooth. There is a lot of changes, and we could figure out from here, right? The MAE was pretty high, so we can actually see that, yeah, the bagging regressor is not working too good. So maybe how to make it better, let's add maybe more data points. So we had added only 2 data points, assuming we can add, let's say, high and low also. So I'm adding today's high and today's low. Let's see if there changes. So currently my MA is 35 and 89. So let's see if it becomes better. I'm going to run it again. So it's become 19 now, and it's become 47. So yeah, it is getting better, but obviously getting the high and the low is very hard during the day. So again, you'll have to probably think of adding some more indicators there to make this better. But I hope you understand the process. If you like the video, please do subscribe. Thank you.